The extension that we added on to Newton's universal law of gravitation yesterday was adding a third mass to the system. So over the past 2 days, I guess on Tuesday and Wednesday, we looked at problems where you would be trying to determine the force due to gravity between two masses if you knew the distance. And we got into other problems where, for number 4 here that you're looking at, you know the distance between the objects and you know the gravitational force. You're trying to find the mass of both objects. And then what we did yesterday is we said, well, look, actually, before I go on, I see I have something highlighted here. On your handout for number 6, does it have that number? It does. Okay, so I've fixed it. I suspect I highlighted it because it was an error before, but I fixed it in your copy. Then yesterday we got into problems like this, where you're trying to determine the amount of gravitational force on one mass due to two others. And some of you yesterday near the end of the class said, well, how do I do number 12 if I don't know any of the masses? You're given the two forces. You're told that central mass is being pulled to the right with 9.0 times 10 to the negative 9 newtons. And it's being pulled, and that's because it's attracted to mass 3. And you're told that mass 2, the center one, is being pulled to the left with 5 times 10 to the negative 9 newtons. And that's because it's attracted to mass 1. And if the question is, what's the net force acting on sphere 2? Well, you have to add these two forces. And what that means is you're going to subtract the amounts. Are you all with me on that? Okay. When you take a look at this one, and this is a good one to talk about here. These are all exam-style questions, or questions that you could see on an exam in one form or another. If I say to you, let's break this into 2, and I want to be mindful to make sure I explain and review enough, but also that I don't leave you with no time to do your work. So I'm not going to go really fast, but I don't want to go too slow either. If you were to take a look at 13a, if I want to determine the net gravitational force acting on sphere 2, then I have to say to myself that sphere 2 experiences a gravitational force due to sphere 1. And I could certainly calculate that using g m1 m2 over r squared. I would also say that sphere 2 experiences a gravitational force of attraction towards sphere 3. And I can see that the gravitational force to the right is going to be less, looking at the distance and everything, but you would calculate those two forces. And then if you wanted to know the net force on the middle sphere, you would add those two forces, but that would involve subtracting the numbers. And I know that you should know this, but I want to repeat that and ask you to really think about it. To add these forces, you subtract their magnitudes because they're in opposite directions. You're still adding the forces. It's just that the method of doing it involves subtracting numbers. When you look at 13b, if you wanted to know the net force acting on sphere 3, well, sphere 3 is attracted to sphere 2. So this is a force due to gravity on 3 by 2. It is also attracted to sphere 1. And I'm not drawing these to scale. I would hazard a guess, and I think you would guess similarly, that force that is pulling sphere 3 to sphere 1 is going to be small because sphere 1 is so far away. So the only point I want to make here is when you calculate this force between 3 and 1, you have to use the whole distance between 3 and 1. Are you with me on that? Okay. And the only other thing I want to review is if we take a look now at, I think, this one. Did I cross out part B on yours? Yeah. That's a pretty challenging question. Or, no, is there one more? Yeah, there's this one. I'm going to go with this one. This is a nicer diagram. I like this. So if you wanted to find the net force acting on the 35 kilogram mass because of the other two, well, you would do the exact same thing we did with, I think it was 13A and B. Was it 13? That one we just did. 4. Okay. So the same thing you would do. I don't know why I didn't just go back. No, with this one. No, that's not what I'm talking about, though. I'm saying to do this, you're going to do the exact same thing we did here. You need to calculate all of the forces and add the forces. Now, how you add the forces is going to change here because of the directions. But in this question, we calculated the two forces acting on that mass we were asked about, and we added the forces. Here, I guess I never finished my thought here. We calculate the two forces, and you would add the forces, but how would you add these forces? What would you do to the numbers, the magnitudes? James? How would I add this many newtons and this many newtons? You'd add them because they're in the same direction, right? Here, you would subtract them because they're in opposite directions. So when you do this one, you're going to calculate using Newton's universal law of gravitation. Sorry, I'm caught in physics 30 right now. You would calculate the force due to gravity. For my explanation, I'm going to label these as A, B, and C. You would calculate the force due to gravity on B by A, and B is pulled towards A. You would calculate the force due to gravity on B due to C, and B is pulled towards C. Then you would add those two forces. This is what I meant when I said the exact same thing. I mean, the details are going to change, so maybe the word exact is not the best choice. We do the same thing. We find the forces and add the forces. The only thing is we're not going to add the numbers because these forces are not in the same direction. We're not going to subtract them because these two forces are not in opposite directions. You're going to draw them tip to tail. So you're going to take whatever force this is, the force between A and B, and whatever force this is, the force between B and C, and to determine the net force and the angle, you're just going to use math. And when I say math, I mean very basic math. Tangent equals opposite over adjacent, then go inverse tan, and the Pythagorean theorem. So in a little while, one of the things I want you working on today are the rest of these problems. Okay? One of the things I would like you to One of the things I would like you never to do is connect these two, because that distance has nothing to do with the question. You don't want to do this. That distance has nothing to do with the question. And that triangle that you're looking at up here, that triangle is not even the same as the triangle that has our answer in it. So drawing this hypotenuse is not only not necessary, it may confuse you into getting the wrong answer. Okay, so I would never draw that. That's got nothing to do with it. All right, now the other thing I want to talk about here, the other thing you're going to be working on today, other than the rest of that handout, is this problem. And I'm not going to go through this assignment question by question. Okay? This assignment that I gave you that's due, what did I say? Tomorrow, I'm going to take it in Monday. Okay? I'm going to take it in Tuesday. You have till Tuesday. There's a danger there because I'm giving you so much time. Don't forget about it. Don't wake up in a cold sweat Monday night and go, oh, I forgot about that. It's due Tuesday. This assignment culminates in getting you to determine the acceleration of this system. Okay? I mean, the first question asks you to do something specific, the second question something specific, but it's really dealing with that. So if I were to draw all of the forces acting on this, and trust me on this, you do not want to draw what I'm drawing on your assignment, because I'm going to be drawing multiple things. And the first part asks you to draw something very specific, and later on it asks you to draw something specific. So it might not be a bad idea for you in your note package someplace or on a blank sheet of paper to just sketch this. Okay? If I said to you, what's the acceleration? Then you have to use F net equals ma. Right? You have to. And I hope it's clear, everybody, that the m in what I'm talking about up here would be the total mass. Okay? And your masses are all different. Your angles might be different or the same, but your coefficients of friction might be different. I'm not going to even put any numbers on my explanation here. What I'm going to do is draw all of the forces, and again, if you're drawing this, it's on a separate sheet of paper. All of the forces acting on this. Well, we have a force of gravity acting on B. No question about it. There are no other forces acting on B. There aren't. That's it. When we talk about A, there is a force of gravity acting on A. But I don't want to draw it. What I want to do instead, I mean, you might be asked to draw it someplace in your assignment. What I want to do instead is understand that there will be a force due to gravity that is parallel to the ramp and a force due to gravity that is perpendicular to the ramp. And I really hope you can all appreciate that the perpendicular component is going to be quite small because of how steep this is. Are you clear on that? That it's, I mean, I wouldn't say it's almost vertical, but it's getting there. And I haven't drawn these to scale. You could certainly calculate these things because you know the mass of A and you know the angle. And the perpendicular component, I believe, is found using cosine, and the parallel component is found using sine. So let me label some of these now. This is the force due to gravity acting on B. This is the force due to gravity acting on A perpendicular to the ramp. This is the force due to gravity acting on A parallel to the ramp. Do we have any other forces? What's one other force, Alex? Friction. And which way, this gets tricky now. Which way is friction acting? Let's leave it alone for a second. Other than friction, are there any other forces? No. The normal force, which is going to be exactly equal but opposite to that force due to gravity parallel. Now, this is a tough problem. This is a very tough problem. Because depending on which way it moves, that affects which way the force of friction is. And that's why I've given you the problem in pieces so you can figure that out along the way. But I still believe there's some value in what I'm about to show you. If the pulley turns that way, then the force of friction is this way. I don't know that it is. And I'm not bluffing either. I can't remember if it is moving that way or not when I made this problem. And what that means, everybody, is This is dirty. This is tricky. If this yellow force is bigger than this force, then we have to say the force of friction is in that direction. If the force due to gravity acting on B is more than the parallel component of the force due to gravity acting on A, then it's going to turn the pulley clockwise. And if it moves that way, box A starts moving up the ramp, which means the force of friction is down the ramp. I don't know that it is. You're going to have to do some calculations along the way to find out. If this is the way it turns, well, if that's the way it turns, that means that the force of gravity acting on A parallel to the ramp, this force that wants to pull the box down the ramp, is more than the force of gravity acting on B. And if that's the case, if this green force is bigger than this yellow force, then the force of friction will be this way. This is the ultimate force analysis. Let's go back to this one. If the force of friction is down the ramp because the box is going to be moving up the ramp, then that means that you have to take the yellow force and subtract both of these to get the net force. By the way, if you take the yellow force and subtract both of these opposing forces, the green and the force of friction, and you get a negative, it doesn't move. Okay. If this is the case, then you're going to have to take this green force, which is the ruling force, it's the force that's going to win the battle, and subtract the force of friction and subtract the force of gravity on B. And again, if you do that and you get a negative, then it doesn't move. I'm pretty sure I know this will move when I designed this problem. I just can't remember if it's going to move one way or the other, but that's what you're going to discover along the way. So when you take a look at question A actually asks you to calculate the two forces of gravity, which has nothing to do with this ramp at all. It's mg. You have to show your work. Then it says calculate the perpendicular and parallel components of gravity on A. At that point in time, you'll be able to compare the parallel component of gravity on A to the force of gravity on B and make that decision as to which way it's going to move if it moves. Calculate the magnitude of the force of friction. Then you're going to have to put that all together by drawing all of the forces. And listen very carefully. I want the diagram to be accurate and neatly completed. And what that means is this. I'm telling you right now. If you get a force of 10 newtons somewhere, and you get a force of 5 newtons somewhere, then when you draw it, you have to draw the force of 10 newtons twice as long as the force of 5 newtons. If you get 10 and 8, then you have to draw the 8 newton force 80% the length as the 10 newton force. I'm looking for a scale diagram here. And that doesn't mean just eyeballing it. It means using a ruler and drawing it properly. And then eventually what you're going to do, once you've got all of the numbers and you've got all of the forces done, develop a formula that can be used to determine the acceleration of the system, explain how the formula was developed, and then use the formula to answer the question. I hope that helps. So for the rest of the class, you have a little bit less than an hour. You're using the time to do this assignment, using the time to make sure you understand everything about universal gravitation, of which we're going to have a quiz on it tomorrow. So a quiz on force due to gravity is G-M-M over R squared. Maybe about a 10, 15-minute quiz. So get to work. I'll come around and I'll help you out.